Right, so we're going to look at quadratic expressions and quadratic equations. And I wrote both of them side by side so that you'd see the difference between quadratic expressions and quadratic equations. Because students sometimes confuse the two with good reason. They're very similar, but there are some subtle differences. Expressions is not equal to anything. There's no left hand and right hand side with the expression. So here I have 6x squared plus 5x plus 1. It is not equal to anything. We could factorize expressions, meaning we could write it simpler. For example, as the product of two brackets, or we call the product of two binomials. Equations, we could solve equations. So equations are different in that we could solve them. So we could actually find out a value or two values for x. So x could be equal to something and something else. That's what happens when we solve an equation. Also, there are two sides. There's a left-hand side and there's a right-hand side. The left-hand side is equal to the right-hand side. So there's this equal sign here in an equation. That is absent in an expression. The approach that we'll use for factorizing and solving is somewhat the same. We use the same first by last method. But the number of steps between factorizing a quadratic expression and the steps in solving a quadratic equation is where we have our difference. There are more steps to solve than there are to factorize. So let's look at factorizing. So we are using something called the first by last method. Right? We are taking this value here, 6, and multiplying it by the last value here. Notice I'm circling the sign too, right? So 6 multiplied by plus 1 is going to give me positive 6. The sign is important, right? Now, the general form of a quadratic expression is that we have ax squared plus bx plus c. So what we're really working out here is a by c, right? And we get its value. We want to find factors of this 6. So factors of 6 include 1 and 6 and 2 and 3. But we can't just choose any random factors. We want factors that could give us what b is. B in this case is 5. So the only two factors that we could use to get a 5, a positive 5, will have to be 2 and 3. Now we could use 1 and 6 to get a 5, but it would mean that I'll have to use 6 minus 1 to give me positive 5. But if I multiply 6 by minus 1, I'll get minus 6, which is not what I want. I want to be able to get positive 6. So this is why 1 and 6 can't work. 2 and 3, however, if I do 2 multiplied by 3, I would get positive 6. And if I add 2 and 3, I would get positive 5. So this is a bit of trial and error that students have to do in order to work out the terms that we're going to split the middle term into. Now, when I'm splitting this middle term, I'm replacing this here with a 2x, positive 2x, and a positive 3x. This remains the same plus 1. This remains the same 6x. So what I'm doing is I am rewriting the quadratic to have 4 terms instead of 3 terms by splitting the middle term, finding another way to write the middle term. I'm not changing the expression because if I add 2x and 3x, I will get 5x. It will just go back to what it was initially, right? So these are like mirror images of each other, so to speak, right? They're not different. Just find a different way of looking at it. Probably mirror image is not the best term to use, but they're the same. If I add 2x and 3x, I'll get back the 5x. The reason I'm doing this is to allow me to factorize. In this form here, up here with 3 terms, I can't factorize because there's nothing common between 6x squared, 5x, and 1. But when I write it as 6x squared plus 2x plus 3x plus 1, I now could factor by groups because now there's something common between 6x squared and 2x. We actually have the 2, that's a common factor, so we're back to factoring by highest common factors, as well as the x. The x is present in both of them. So 2x into 6x squared, 2 into 6 will give me 3, x into x squared will give me x, and then 2x into 2x will give me 1 and not x, right? Very important. A lot of students make that mistake. Think about like writing it like a fraction. If I put 2x over 2x, they will both cancel out and I will get 1. Now, from our grouping stage before, I am copying this bracket on this side here. And then I'm just comparing these terms. Now 3x and I have the same 3x plus 1 here. So what am I going to put out here? It's a bit confusing, right? But what we have to put here is actually plus 1. 3x squared into 3x will give me plus 1. Plus 1 by all of this will give me back the 3x plus 1. Now at this stage, both this bracket and this bracket is the same. So I could factor that out, right? I could factor 3x plus 1, and I could put the 2x plus 1 in a bracket. Now, just like with factorization, we could check our answer. We could check our answer by expanding this bracket, because expanding the bracket or two brackets binomials and factorizing a quadratic is actually the reverse of each other. Expanding the bracket will give me back the original quadratic that I started with. So if you work something out and you're not sure and you want to check your answer, expand your bracket. 3x by 2x will give me 6x squared. 3x by 1 will give me 3x. 1 by 2x will give me back the 2x. And 1 by 1 will give me 1. See how we get back to this line here? And if I add those two middle terms together, I'll get 5x plus 1. So these are actually the reverse of each other. When we factorize our quadratic expression, we are trying to get back to the original brackets that we expanded to get that quadratic in the first place. Yeah, everybody understand that? Give me a little thumbs up. Right. Now we're going across to the side. Now, as I mentioned before, the method is the same. So I will use the same first by last method. In this case here, this is a 1 in front of this x. So 1 by 2 will give me 2. And factors of 2 is 1 and 2. And we could easily see if we want this middle term to be 3, then we're looking at 1 plus 2. Right? So I'm going to split this middle term into, well, you have to put x, right? So we could say 1x and 2x. And put back our 2, put back our equal sign, put back our x squared. And we're back to factorizing by groups again. If we look at this group here, the common factor is x. X is common to these two terms. X into x squared will give me x, and x into 1x will give me 1. The x's will cancel. I have to copy this bracket back on this side. This and this has to be the same. And if I compare this term and this term, what's missing? The plus 2. Plus 2 by x will give me back plus 2x. Plus 2 by 1 will give me plus 2. Now, these two brackets are the same. So we could factor that out. And I'll get x plus 1. I will put the x plus 2 equal to 0. Now, this is where we go one step further. When we are factorizing, we will stop here. But we want to solve. If we want to solve, it means that we need to find out a value for x. So we're going to take each of these brackets and put them equal to 0. And we'll separate each of them by a colon. So I have x plus 1 is equal to 0. X plus 2 is equal to 0. And then we solve like we usually would any linear equation. Carry the 1 across. We're going to get negative 1. Carry this 2 across. We're going to get x is equal to negative 2. Right? So for a quadratic equation, you would usually get two values of x in most instances. Right? And that's how we do quadratic expressions and quadratic equations. Yeah? All right, folks. So let's look at solving these, well, factorizing one and solving the other. All right, let's start with the factorizing first. So we have 2x 6x squared plus 9x plus 3. Now, this is where most students have the challenge, right? Splitting this middle term up. After you do a couple, the key to this is practice. So you do a lot of practice and you'll start to eventually see the numbers like instantly. So you know you have to multiply 6 by 3, right? And we know 6 by 3 is 18. And we're looking for two numbers that we could add together to give us this 9, but still multiply and give 18. And this one kind of easy because 6 by 3 will give us the 18. And 6 plus 3 giving us 9. So we know we're splitting this into a plus 6x and a plus 3x. Always important to put back the x, right? Because remember this term, middle term, is in terms of x. We put in back this plus 3 here. We put in back this 6x squared here. Once you get our 4 terms, you can put your brackets here one time so you know you're factoring by groups. And then focus your attention, on the first bracket. Just factor that and everything else would move smoothly after. You're not going to do double factorizing and factorize the first bracket, then the second bracket. That could lead to some confusion at times. So let's just look at this. Looking at this, this is very simple. You could see that 6 and x are common factors to both terms 6x squared and 6x. So we could pull out 6x. If I take 6x out, 6x into 6x squared will give me x. The 6's will cancel. X will go into x squared and leave me with a x. And then 6x into 6x, remember, you're not going to get x. They will cancel and you'll get 1. Once I get this bracket here, I am writing this bracket on this side because the two brackets must be the same. Right? We don't want to try and factorize anything. We copy in the bracket because it's going to make our lives easy. Because what we will then do is just compare this x here and compare this here, and what's missing? We don't even have to work anything out. We could clearly see that the plus 3 is what is missing. And just double check it with plus 3 by x will give me back my plus 3x. Plus 3 by 1 will give me back 3. And now, these two brackets are the same. So I could actually factor that bracket out, x plus 1, and put these two terms in our bracket. So I get 6x plus 3. And that's our factorization of 6x squared plus 9x plus 3. Let's go on the opposite side now. We want to solve. So we still need to do the first by last method. Now remember, if you have an x squared with nothing in front of it, there is something in front of it. We just don't write it. It's a 1. So this is 1 multiplied by positive 7. Again, this is an easy one because 1 by 7 is 7. We want to split this middle term, and it has to be 8. So 1 plus 7 is going to give us 8. So this is 1x, or plus 1x plus 7x. You could put back the 7 here, put back equals 0, put back your x squared here. Now we go in again with our grouping. So when we look at this first group here, x squared and x, the thing common is x. X into x squared will give me x. X into 1x will give me the 1. That's why I deliberately put our 1 there. So you'll know that 1 coming back. Copy this bracket. We're not playing any hero. Copy the bracket and then just compare this and this. What is missing? You can clearly see the plus 7 is missing. Double check. Plus 7 by x will give me plus 7x. Plus 7 by 1 will give me back the 7. Let us put back the people 0. You're going to get x plus 1, write it once, and then the x plus 7 within our bracket. Now, we're not done here because we're solving. We need to get x is equal to something. So we get x plus 1 is equal to 0. X plus 7 is equal to 0. Right? You can separate them with a semicolon. And at this point, I don't need the brackets anymore, right? So removing the brackets. This will give me x minus 1. And this will give me x minus 7. Everybody right to that? Everybody got that? So that is solving and factorizing quadratics.